Hello, in this video I'm going to go over how to find the equation of a line when you're given either the slope and a point, a coordinate on that line, or you're actually just given 2 points that are on that line. Okay, and when I say find the equation of a line, usually when you're starting out doing these, we want to end up with the equation in the slope-intercept form. Slope-intercept form, which is really, we call that y equals mx plus b form. So you're going to take the information, okay, and either going to get a slope and a point, or I'm going to get 2 points on the line. I'm going to show you 2 methods of how to solve this, okay? So first, let's take an example. I've got write the equation of a line in slope-intercept form, so the y equals mx plus b form is what I want to end up with, okay? And this particular line, it has a slope of 3/4, and it goes through the point 10, 12. Okay, so I need to find the equation of a line. Now I'm going to show you there's 2 methods that you can do. Okay, first of all, I have to keep in mind, what do I have? I've got the slope is 3/4. Remember, we use m to represent slope. And the other thing here is that, see, I've taken the point 10, 12, and I wrote underneath it x1, y1. Okay, why do I do that? Because there's infinite points on that line, of course, because it goes on forever. So what if I wanted to list different points in the line? I want to kind of keep track of which point's which. So maybe the first point that I list, I'll call that point 1. And the coordinates are, the x coordinate is the first x coordinate, and the y coordinate is the first y coordinate. So in other words, that'll be my point number 1, and I will call x1 is 10, and then y1 is 12. So that keeps track of it. That's why we write that. Okay, so that's my information right now. And now I'm going to use something called the point slope formula. Okay, and the point slope formula is really when we're going to have a little formula we can plug into. Now here's the point slope formula. All right, take a look at that. It is y minus y1 equals m parentheses x minus x1. So when we do this, we're going to be plugging in. Remember, I just talked about we have m, which is a slope. And then I was talking about the coordinate I had, which I called coordinate 1. And I had an x coordinate, y coordinate. And the x coordinate is x1. And then the y coordinate was y1. So I'm going to take that information and just plug it right into this formula. It's going to be nice and straightforward. Okay, so recall the slope, m was 3/4. And then we also had the coordinate. What was the coordinate? The coordinate was 10, 12. So I'm going to write, now notice when I write this, the y, the letter y, that stays y. Because, you know, when you end up with an equation like y equals mx plus b, you might have like y equals 3/4x plus 7 or something like that. You still have to have the letter y and the letter x in it, or usually you do. But so I need to have just plain y. I don't plug in anything for that y. I just write the letter y. Now this one right here, when it says minus y1, that's where I'm going to actually use the coordinate, the y coordinate that I had. And then what was the y coordinate? Remember, here the coordinate we had is 10, 12. And the y coordinate, in this case was 12. y1 was 12. So I'm going to put in 12 for y1. I have an automatic equal sign. Now it's time to put in the slope, which again was 3/4. So I'll put that there. You have to have a parentheses. Again, like I put in the letter y, I just put in letter x. I have a minus, and now it's time to put in the x1 coordinate, the sample x coordinate of that point. Again, the x1 there was 10, so I put that in there. So right now I've got the y minus 12 equals 3/4. Then you have a parentheses x minus 10. Now, that actually right there is a type of form of equation. That is actually called the point slope form. So that sometimes teachers want you to just do that first. That's left in the point slope form. But I had asked, how do I get it into the slope-intercept, which slope-intercept is the y equals mx plus b form. So from here, what am I going to do? All right, to get to y equals mx plus b form, I'm going to need to first distribute, okay, that 3/4 times what's in the parentheses. okay, because it's right outside the parentheses. Remember, distributing, you're multiplying what's outside into what's inside. So when I do the 3/4 times x, of course, that's 3/4 x. Okay, then you're going to have, you have the automatic, well, now I'm going to multiply 3/4 times 10, but notice there's a minus sign. I'm going to keep that. And now when I do 3/4 times 10, I get 30/4. So I'm going to write that down there, 30/4. And then I'll just rewrite what I've got there. I didn't change anything on the left side yet. But I have to get y alone. I have to get that 12 out of there. So I'm going to add 12 to both sides and add it over there. That will eliminate it on the left side. Okay. But now see what I've got is I've got over on the right side, you have 3/4 x. And then you have some numbers that it don't have a variable in it. These are like terms, right? Because they're just numbers. You couldn't combine any of these with this 3/4 x because it has an x in it. But what I need to do is combine these. So we have to be careful here because see that right there? It says minus 30/4. That means that's going to be a negative number. Okay. Well, the other thing too is that when we're dealing with, notice how 30/4 is actually 7.5. This is something to point out when you're dealing with these equations, these line equations. The slope part, remember the slope is just how much something the line rises compared to how much it goes sideways, right? It's the change in y over the change in x. We always leave that as a ratio or as a fraction. It's just, if it's a whole number, that's one thing, but if it's not, we leave it as a fraction, and you leave it, even if the number on top is bigger, you're going to leave it as an improper fraction, not a mixed number. But so we want slopes to stay in that fraction form. However, the plain number over here, which in our y equals mx plus b form, that's going to be your b, and that's going to tell you where it crosses the y axis. So the point is that I don't need this to be a fraction. In fact, it's more clear if I have just a decimal. So right now I'm just saying 30/4, that is 7.5. Okay, but of course it's going to be a negative 7.5 because the minus is going to affect it. So I'm going to have the pretty much, you're really going to have, you have a positive 12, and then you're subtracting a 7.5. Well, what do you get there? Okay, that actually comes out to be 4.5. So now I can clean this up. Notice I got rid of the 12 over here, so I just have plain y equals, this is all set, the 3/4 x, and then I'm going to put, this is a positive 4.5. Now that's my equation. That equation was, get back here, the equation was y equals 3/4 x plus 4.5. Okay, keep that in mind. So that was method one. Here is another method which it's similar, but so let me recall what I had. I have m is 3/4 and the point was 10/12. I'm going to show you a different way to do this. And it isn't a formula like I just did with the point slope formula. What it is I'm just writing down the equation. So this is my slope-intercept form of the equation for a line, which is y equals mx plus b. So when I do that, what I'm going to do is I'm going to just plug in what I know. And notice, so what I'm doing is I'm just going to take my slope and my x and y. Notice in this equation right here, you really have four parts. You have a y, I don't mean the equal sign, but you've got a slope. So that's the second part. You've got an x, that's the third part. And then you have a b. Okay, the y-intercept. That's four parts. Well, if you look at right here, notice I've got a slope. That's one part. I've got an x. That's a second part. And I've got a y. That's a third part. I've got 3 out of the 4 parts. I can plug these all in, and then I don't have b, but I can find it. Once I know all of these, I can plug it in, and I can get that. Okay, so let's see what happens when I do that. Again, so I'm going to, and for y, I'm going to use the 12. I have an equals, then I put in the slope, which is 3/4. Now, I put in the x, I have to multiply it times that 10. And then you notice how I just have plus b. So right now what I did is I plugged in the 3/4. I plugged in the, right there, I plugged in a sample y coordinate and a sample x. And I'm going to multiply this together here to find out, subtract it from this and get what b is. So again, I'm going to get 3/4 times 10. And that gets me we know that that was 30/4, which again was 7.5. So right now what I've got is I've got 12 equals the 7.5 plus whatever b is. So what do we do to solve for b? Subtract 7.5 from both sides, and that comes out to be 4.5 equals b. So now I have solved for b. So now I just have to go back and rewrite it in the y equals mx plus b form. So we go back to just writing the letter y. So I use the y and the x to solve for b. But now I go back and I write y equals, I do put in the slope. So notice I go back to writing y equals, okay, because the 10, 12, the 12 for the y, the 10 for the x, that was just one coordinate on there. I have to go back to the actual equation form. Y equals 3/4 is the slope, because that's not going to change in the whole question. Like, that is the line slope. All right, 3/4 x. Now I put in what b is. Now I solve for b, it was 4.5. So again, that line will only have that slope. That line will only cross the y-axis at 4.5. The x's and y's can change. But see how I plugged in a sample x and y point and then the slope and found b, and then I went back and rewrote it. Okay, so there's not really a name for that, of just using y equals mx plus b and plugging in. All right, so that's two different ways to do that, and it just depends what the teacher asks you to do. But I think as students go on in algebra, they really end up, most students will end up doing this a little bit faster, and you get right to the form you need. Okay, so going forward here, I have another question now, and it's saying also find the equation of the line in slope-intercept form. This time I don't have a slope, I have two coordinates. All right, the coordinates -4, 6 and 4, 0. So what do I need to do first? I have to have a slope, okay? So those are my points, and I'm going to do the point slope form again, which I showed you first, which is the y minus y1 equals m parentheses x minus x1. But notice I need a slope. How can I find a slope from two coordinates? So notice now what I'm doing is, remember I said before, the x1, the y1, that means my first point. Okay, so in this case, I'm going to call x1, y1 the -4, 6. Okay, because the coordinate is -4, 6. When x is -4, y is 6. And I'm going to say, oh, here's a second point on this line. So I'll call it the second x coordinate, or x2, and I'll call this the second y coordinate, or y2. It just keeps, when you're doing the slope formula, from mixing them up. But I want to point out here is that, see how I have this one as the x1, y1, and this one x2, y2. It doesn't matter which one you choose as x1, y1, and x2. See, I'm going to switch it. I'm going to say I could have called this the x2 and y2, and then this one the x1 and the y1. It doesn't matter. It's just that you don't mix up and say, oh, I'll put the second x coordinate with the first y coordinate. It keeps track of it. Okay, so now I've got those points. I need to find the slope, right? Why do we define the slope? Well, what's the slope formula? The slope formula, recall that is, we'll do the y2, all right, minus the y1 on top. Then underneath in the denominator, we're going to have x2 minus the x1. Okay, that's going to get us our slope. So plugging in there, I said, okay, let's say y2 was 6. So that goes there. Subtract the y1, which was 0. And then on the bottom, I'll take the x2 right here, the -4. And then I'm going to subtract the x1. See, that's nice and organized, so I can just look up at what I've got. So the x1 is the 4. So that's going to go, so we have x2 minus x1. So we have -4 minus a 4. All right, so now I can calculate that when we have on top the 6, and on the bottom, -4 minus 8, minus 4 is -8. Okay, that will simplify to 3/4, but remember, it's a negative sign in down in the denominator. We generally don't want to leave it there to work with. What I'm writing now, I could write it as negative, see, in front, and then do the 3/4, but it's really helpful if we put that, see right there, that's out front of it. It's not in top or bottom, but you really want to work with it, putting it, so this is correct, but it's more helpful if I put it up here in front of the 3. Okay, it's just, trust me, it's easier to multiply things with that. Okay, so now that I've got my -3/4, what am I going to do with that? So I'm going to plug it in. Remember, this is the point slope formula. All right, and then we've got -3/4. So like I said before, you leave this y, you leave it as y. Okay, and then I'm going to subtract y1. And then I've got my slope, and then I have parentheses, and I'm going to leave this as x. Okay, so when it says y and it says x, I'm not changing them. They're going to be y and x. The y1 and the x1, those are the specific point coordinates. Okay, so, but now I said I need x. Notice I'm not using x2, y2. I only need one set of coordinates here. And like I said before, it really doesn't matter what you use for x1 and y1 versus x2, y2. But so as long as they're matched, okay? So notice I could use these coordinates for the x and y, or I could use these. I already said right now I have this label x1 and y1, and sometimes too if one is 0, it makes it a little bit faster, but either way would work. So that's my information going back to the point formula. All right, so I'm going to use the point -4, 6, or I can use 4, 0. So it doesn't matter, but I'm going to go ahead and say I'll use this one because it does have a 0, might be a little easier. But so now I need to plug in. I've got x1 is 4 and y1 is 0. All right, so up in the spot where I have the, this is the y, and then I have minus y1. Okay, so y1 is 0. And then I've also noticed I've got here is minus the x. So this is one way I could do it. I have got, this was a 4, so it's minus 4. So there, from there, the nice thing is that actually just goes away, and I've got y equals. Now, what do I do here when I have this parentheses here and I have the slope out front? You need to distribute. You need to multiply that -3/4 into both this term, the x, and this. I'm going to leave that as a minus. All right, so I'm going to do the -3/4 times x. Well, that's just going to get me the, yeah, leave the minus there. This is going to get me -3/4 x. Now, see, I have the minus sign. You got to put the minus sign there. Right there. Then I do -3/4 times this, just the 4. Okay, so I'm ignoring that for a second. I'm going to just keep it there. And all I have to deal with is a -3/4 times a positive 4. So -3/4 times a positive 4. Well, nice thing is that the 4s will cancel. So I have a -3. All right. I still have that minus subtraction sign there. Now I'm going to have a -3. So I'm going to put that in there right in front of it. So I've got -3. So now we have minus a -3. Okay. You're going to do, when you have minus a negative, subtracting a negative, that you're going to know two negatives, it's going to become a positive 3. All right. And then I'll just write the -3/4 x in front of it and the y equals. Now I have just found, using two coordinates, I found the equation in the slope-intercept form. So notice we call it the slope-intercept form, this y equals mx plus b, because slope, intercept, y-intercept. Okay, so if I'm going to do that, that is using the point slope formula there, right? Okay, now what if I just use my method, the shorter method, when I just say, okay, let me just take the general equation y equals mx plus b, okay, and plug in and solve for the b. All right, now I remember I already found my slope, so I'm not going to redo that. It was -3/4. And let's say I can use either -4, 6 or 4, 0. Remember, there were two coordinates that I was given. You're only going to use one of them. So I can do, let's just say, so again, this was one of the sets, and then this was another one. So let's just say, switch it up. Let's say I'll use this coordinate now, okay? So now I know I'm not using x1, y1 and that stuff right now, because in this method, you're just putting in a sample y coordinate for the y. So I'm going to use this. I'll use this coordinate, right? So for y, when y is a 6, all right, it equals, then I put my slope in of negative 3/4. Now I'm going to put in an x value, okay? Now, so I'm going to put the x in parentheses right now, so I'll remember to multiply them, because what is the x? It's a negative that goes with this coordinate right there. The x at this point is a negative 4. Definitely need to put that in parentheses right there, okay? Negative 4. The reason you have to put it in parentheses is because I don't want to just go slope negative 3/4 and then just write -4. I'm going to think it's subtraction or something. And no, I'm not. It's not really distributing technically when I do negative 3/4 times a negative 4, because there's only one term in there. But again, you can see how it just keeps it that separate in there, so you don't get confused with that sign right there. So now I will multiply the negative 3/4 times that negative 4, and that actually comes out to be a positive 12 over 4, which simplifies to a 3. So I have 6 equals a 3 plus b. Nice thing again here, I'm just going to find out what b has to come out to be. Subtract 3 from both sides, and you're going to get that 3, or b is 3. Right there. Now I can go back and rewrite this equation, going back to where it just says y equals, then I put in my slope, negative 3/4, and I go back to x, and now I can put in the b coordinate, or the b. And the b was a +3. Okay, so now I've gotten it that way. So see how it compares? It's the same thing. So that's how you do this. You have to find the equations of lines, and you're either given a slope and a point, or you're given 2 points on the line. And again, there are 2 methods. You should know both. Again, sometimes a teacher will specify you have to do one versus the other. And then, you know, later on, they'll just let you kind of find it whatever way is best for you. So hopefully that helps. And if you like this video, please hit like and the subscription button so you can find out, and a notification bell so you can find out when I'm putting more and more math content on here and help you through your math studies.